All right, so with the solution that we submitted, we clearly noticed that the time complexity is high. It is evident in the runtime being so high, and in terms of big O also, it is n square. So it is quite high. What are the options to optimize the solution? If we look into the lead code sections for solutions, they have one solution which does not look very pretty but does the job in you know in rather very quick time in comparison to the solution that we had. So let's just run the code. What's going on? Oh, come on, lead code. So yeah, it's just that the for some reason the solution section has variable as a, whereas the submission section has variable as ar, which is fine, not a big deal. So let's run the code. So it runs fine, and then when we submit it, we would see a low latency in comparison to the runtime is 3 millisecond in comparison to the time when we were submitting with our previous solution. So almost like 700 times less latency for the program. Now, from where all these constants are coming into this program, usually I would vary using any constants, because then the solution that you are building is not generalizable. It won't solve problems beyond the constraints that you might have at any given point in time. So there are some constraints that are mentioned in the question. Length is not going to go beyond 3000. The number, the element value in array is not going to go above 100. Target is not going to go above 300. And this program uses those constraints really well to deliver something which is faster, way faster than what we were looking at in our brute force approach. It has a loop which is counting the occurrences of a given value. So for our example 112255, the count at 1 would be 2, count at 2 would be 2, count of 5 would be at 2. And then it goes at looking at different options, like if x, y, z are different. What it does is that it looks at z as target minus x minus y. So only if the z there is the count z has some value, then only the answer would be would have some value, otherwise it would be 0. So by the mechanism of these two loops, and z being target minus x minus y, this program makes sure that we are looking at the right combination, and not like something which does not add up to the target. So that's what it do. And then if there are other combinations where x and y are same but z is not same, so z in that case would be target minus 2x. So it will again check if there are some combinations, then it would add some more values to the answer, which means that more combinations are supporting that target. In our example, we did not have any, so the count of z would be 0, and the answer would remain what it was when we went through the all different case. And again, if y and z are same and x is different, then we have another set of instructions. Now all these instructions are with, although they have loops, but the loops are going to a constant length only. So as such, in terms of big O, it is only constant time that this program is adding. So yeah, so our case is not going to land up in it's not going to add any value between these loops. And then if x, y, z and are same, then also that's not the case for us. But and then the answer goes back. Now let me just go a little deeper on what are these things doing here. So supposedly if our array was like in this case, if it assumes that our array is like 1111 and then say 2 and 2, and target that we need is 3. So all it is saying is that the x here is 1, y here is 1, and z here is 2. So in this case, how are we going to calculate the sum? So we know that in count 1 is counted as 4 and 2 is counted as just 2 count of 2 would be 2 and count of 1 is 4. Now how are we going to calculate the right occurrence for the y value that we have here? How we will do that? It is like the combination. So out of 4 we have to find 2 combinations. So it is like 4c2. So in terms of factorial, it would be like 4 factorial divided by it, the combination is calculated as like NCR, and that is n factorial divided by we are divided by n minus r factorial multiplied by r factorial. So that is the value that we will have to find out. Now how does that happen? Like for example, in this case it will be 4 factorial divided by 2 factorial multiplied by 2 factorial. And what does that become? So that becomes 4 into 3, and 2 factorial will go away with 2, and then we have a 2 as well, and that is what we are doing here. So count of x is 4, and then we are doing count of x minus 1 divided by 2. So this is essentially the factorial that we are taking by doing that mechanism. We know that only 2 factorial is the one that we want how many combinations we want. 2 combinations. So instead of calculating factorial, this program is doing a little bit smartly. Otherwise your time complexity will go a little bit more higher. And same thing it does when if for conditions where y is equal to z. And similar approach it does when we are looking at if all 3 are same. Here what happens is, again with an example, let's say count target here should be 4. So here target is 3. So what we are saying is that x and y and z all 3 are same. But in our count array we only will have value for 1, and that will be 6. So how would we calculate that how many combinations we could have for 3 such pairs among 6 elements? So that will be like 6 factorial divided by 3 factorial multiplied by 3 factorial. And what does that become? So that becomes 6 into 5 into 4, and in the division it will have only 3 factorial left, and which is 6. So that is what it is doing. So in this example, count of x would be 6, count of x minus 1 is 5, count of x minus 2 is 4, and divided by 6. So divided by 3 factorial in a sense. So that's it, and then it returns the answer. Perfect. I think that's all from my end. Let me know if you have any questions for me. This definitely is an interesting question, and if we have to solve it with a very low time complexity, then it definitely needs some thinking. Thanks for watching.